Proxima b, the planet that still poses many mysteries, is back in the headlines. It was once announced that life on this planet was impossible, but now researchers have found evidence of artificial light in the exoplanet's environment. The James Webb Telescope is now expected to provide a clear image of the planet and finally clarify whether we are dealing with an Earth 2. The exoplanet Proxima b was discovered in 2016 using the radial velocity method. Researchers at La Sierra Observatory in Chile used the HARPS telescope to detect the influence of an orbiting planet in slight repeated movements of the star. The accuracy of the measurements and the deviations in the star's movement revealed to the researchers the presence of a planet roughly the size and mass of Earth, and further research provided evidence that we are dealing with a super-Earth. In 2020 and 2022, the Proxima system was re-examined with the Espresso telescope in Chile. The very large telescope on site took new measurements of the radial velocity and deviations, confirming the mass and orbit of Proxima b. The Espresso researchers achieved even greater precision than the HARPS mission had previously achieved, enabling the research team to confirm the approximate mass of Proxima b. The value of approximately 1.17 Earth masses further indicated that it's a rocky world and an Earth-like planet. However, measurements like these cannot provide any information about an atmosphere, water, or life. This is where the James Webb Telescope comes into play. NASA's new space telescope can use infrared analysis to determine exactly which elements and gases are present in a planet's environment. To do this, the telescope spectrometers analyze the light that a planet absorbs from its star and then remits. The surface properties of the planet and its environment alter the light waves in very specific ways. And the telescope's instruments read these changes to detect traces of gas such as oxygen, methane, carbon dioxide, and the presence of certain metals or water vapor. Proxima b, what did the telescope find? It was a shock when the Hubble Space Telescope examined Proxima b shortly after its initial discovery and found something terrible. The old space telescope observed stellar flares from the star Proxima Centauri and extremely high levels of UV radiation. The radiation environment around the planet was rated so high that the presence of an atmosphere or life on Proxima b could be ruled out. The horror data was confirmed by X-ray observations with the Chandra and XMM Newton telescopes. Measurements of X-ray radiation from Proxima Centauri showed flares up to 100 times stronger than solar flares, further reducing the habitability of Proxima b. The final mission to find traces of life or an Earth-like planet in the Proxima Centauri system was undertaken with the Atacama Large Millimeter Submillimeter Array, or ALMA for short. As one of the best Earth-based telescopes currently available, ALMA meticulously searched for signs of dust disks in our neighboring star system. These could be further possible indications of previously undiscovered planetary system structures. At the same time, Proxima b was re-examined. The existence of Proxima c was confirmed, and indications, but not definitive evidence, of up to 3 additional exoplanets were found. Now researchers have surprised everyone with a brand new study that claims to have found evidence of artificial light on the dark side of the planet Proxima b. Due to its bound orbit, the planet has a night side and a day side. Traces of light have now been detected on the side that is perpetually shrouded in darkness. But how can this be? In a statement, researchers offered 3 possible explanations. First, light particles could be carried from the day side to the night side of the planet by orbital currents. Another possible source could be geological activity, such as intense volcanism. The third realistic possibility is that these are actually artificial light sources. This would mean that there could be cities or other technological facilities on the dark side of the planet. What is fascinating about this idea is that researchers announced several years ago that we cannot rule out the possibility of life on Proxima b simply because the radiation on the side facing the star is extreme. A narrow belt between the day and night sides could offer good living conditions, and perhaps also the night side. If we look at life from a new perspective, we don't know for sure under what conditions advanced life develops elsewhere. We cannot rule out fantastic things such as radiation-resistant organisms. We cannot rule out the possibility of vegetation existing in complete darkness. On Earth, this is demonstrated by plants and animals that thrive in complete isolation and without light in caves deep underground. We know of bacteria that grow in boiling hot and toxic hot springs. And ultimately, all complex life in this world originated from such simple organisms and bacteria. In our case, this was mainly based on water and oxygen because these are abundant in our world. It's possible that creation elsewhere uses other building materials and abundant substances to create other forms of life. Proxima b, the surprise is complete. What happens next? The extremely large telescope of the European Southern Observatory in Chile should provide certainty. The ELT is currently undergoing reconstruction and upgrading. It will be located on Cerro Amazones in Chile's Atacama Desert and will take the most accurate measurements in the vicinity of Proxima b with a main mirror measuring 39.3 meters in diameter. It will be the largest optical telescope on Earth and will once again examine light emissions from Proxima b. With its enormous light-gathering power and adaptive optics, the ELT will be able to produce extremely high-resolution images using instruments such as METIS for infrared observations and Harmony for spectroscopy. The ELT will also be able to analyze the atmospheres of other exoplanets directly. Even for planets orbiting red dwarfs only a few light-years away, as is the case with Proxima b, accurate results will become a reality. The ELT can easily detect biosignatures such as methane, water, or oxygen and precisely analyze the chemical composition of exoplanet surfaces and atmospheres. What is particularly exciting is that the telescope's high contrast and resolution make it one of the first telescopes that could enable true direct imaging of Earth-like exoplanets in visible light. As the earthly brother of the JWST, the ELT will also play a key role in the exploration of dark matter, the early universe, and galactic formation processes. But that's not the end of the innovations. NASA's LUVOIR, or Large Ultraviolet Optical Infrared Surveyor, will be a new superstar in the 2030s. With a main mirror up to 15 meters in diameter, the telescope will be more than twice as large as the JWST. LUVOIR will be a true all-purpose telescope, observing the universe in the UV, visible, and near-infrared ranges. The project is currently still in the concept phase. However, NASA spokespeople recently confirmed once again that funding for the new superlative space telescope has been secured and the project will go ahead. The telescope would be equipped with extremely sensitive coronagraphs to block light from stars, making planets in close proximity to their stars, such as Proxima b, directly visible. This would allow the analysis of atmospheres, cloud cover, and potential technosignatures. LUVOIR could identify even the smallest traces of ozone, methane, and even substances such as chlorofluorocarbons, gases that would indicate industrial activity. LUVOIR will also devote much of its time to systematically surveying Earth-like planets in habitable zones. It's the most ambitious telescope concept for the direct search for life, with a scientific objective that goes far beyond what the JWST can achieve. So will we soon get an even clearer image of Proxima b than the Webb telescope can provide? Definitely, because technology never sleeps, and space exploration is currently experiencing a renaissance. What can NASA's HABX, Habitable Exoplanet Observatory, do? Did you think we had already reached the end of superlatives and space exploration? Then we need to talk about HABX for a moment. This is another telescope concept from NASA that is being developed in parallel with LUVOIR. However, HABX will be equipped with a clear focus on exo-Earths and their habitability. In plain language, this means that HABX is being developed solely to find super-Earths and life in space. It's planned to be smaller than LUVOIR and will be more specialized with a mirror measuring approximately 4 meters. A key feature is the planned starshade, which acts like a flower-shaped sunshade, shielding starlight and making the light from exoplanets directly visible. With this technology, HABX could target individual stars such as Proxima Centauri and search their planets for water, oxygen, ozone, and other biosignatures. Since the observation is completely free of glare from starlight, researchers expect even more accurate results than with any other super telescope. The combination of direct imaging and spectral analysis should then work with unprecedented purity. And unlike James Webb, HABX can also observe in the visible and infrared spectrum. The visible light ranges could contain a particularly large number of biologically relevant lines. HABX will therefore be far less versatile than LUVOIR, but is tailor-made for targeted exoplanet analysis. If it's actually built, HABX would be the first telescope capable of truly identifying and characterizing a second Earth in another star system, and Proxima b would certainly be at the top of its list. The project is currently in the concept phase. If enough investors can be found, NASA says it will begin the hunt for life in space in the late 2030s. We won't have to wait quite as long for NASA's Nancy Grace Roman Space Telescope. This new flagship project is set to launch in 2027 and will bring a number of innovations. The Nancy Grace Roman Space Telescope, named after the mother and co-developer of the Hubble telescope, will be sent into space in 2027 to complement JWST. Incredibly, it's based on a former US government spy satellite and, like Hubble, has a 2.4-meter mirror with a field of view 100 times larger. Nancy Grace Roman will primarily be used for large energy research, gravitational lensing, and large-scale galaxy surveys. But the telescope is also suitable for searching for exoplanets. A special coronagraph technology demonstrator on board will show how well planets close to their stars can be directly imaged in visible light. This is intended as a technical precursor for projects such as LUVOIR and HABX. Although Nancy Grace Roman itself cannot directly image Proxima b, the technology represents an important technological intermediate step in significantly advancing the precision required for future planet hunters. The Roman telescope will also help discover thousands of new exoplanets in the galactic plane through microlensing effects. Subscribe to the channel now, the best videos are yet to come.